Hello, today we're going to talk about inheritance and subtype polymorphism. This is supposed to be a review lab style session, so let's get started. So let's just imagine we have a toy class over here and we want a robot class to inherit from it. The toy class would be the base class and the robot class would be the derived class. So how we do it is the syntax is we have a class robot and we use this colon to say that robot inherits from toy. Let's look at the public keyword over here. What this public keyword says is basically that whatever was in the public section of toy would end up in the public section of robot. If we have a private keyword instead, what it means is whatever was in the public section of toy would end up being in the private section of robot. So a question you may be asking is, what happens to this private section of toy here? So a question we can ask ourselves to answer that question is, can derived class access the private members of its base class? So basically, can robot access the private members of toy? The answer is no. So robot cannot access the private members of toy. We can think of it in this way as in like private having a box around it. So the only thing that can access the private data members is the toy class. Let's move on to constructor and destructor. What is the order of constructor being called? So we have a robot constructor over here, which is the derived class. When a robot constructor is being called, it will first call the toy class constructor because that's the base class. Then only it will call the derived class the constructor. For destructor, it's the other way around. It will call the robot class destructor, then it will call the toy class destructor. So let's just look at this over here. When there's a function, when there's the constructor implementation like this shown, what happens is like the toy constructor will be implicitly called over here. But what if we don't want to call the toy default constructor because it will implicitly call the default constructor every time? We have to have a member initialization list and we have the toy non-default constructor over here. Let's just think, can we call it in this way? Can we have robot over here, then we call the non-default constructor here? We can't do that because what happens is like the toy default constructor will be called here anyways. So this would essentially do nothing. So let's just ask, what happens when toy does not have a default constructor, but we have this implementation over here? The answer is that an error will get thrown because it will expect a default constructor. It will try to call the default constructor, but if there's no toy default constructor, there will be an error. So let's just think about function lookup now. So if we have a base class here, which is toy, and we have a derived class here, robot, with the same functions, we have void make sound. It occurs here as well. If we have a robot object and we have the robot object call the make sound function, which version will it call? Will it call this version, the toy version, or the robot version? It will call the robot version over here because it will look for the derived class. It will look for the function definition in the derived class first, and if it found it, it will use the derived class version. But if there is no such function over here, it will move on to the base class to look for the make sound function. And if there's none in both of them, there is no function definition for make sound, and there will be an error because this function will not have been defined. So let's think about object slicing, indirection, and subtype polymorphism. It's a mouthful, but let's just think about why do we need subtype polymorphism. Whenever we have this being declared a toy and robot and we try to assign the robot to a toy, it will result in something called object slicing. So let's just look at it a bit over here. Let's just say this is the toy object that we have. This is the toy object that we have, and this is the robot object that we have. We have everything that is toy and also this robot object here. So whenever we want to assign robot the toy, there's only this amount of space. It's a very limited amount of space. So what it has to do is it will throw away the robot properties of robot and essentially only have toy left in it. So this is called object slicing. It will remove the robot parts of robot before assigning it to toy. So the way we overcome this is we use subtype polymorphism, we use pointers to toy, we use pointers to robot, and we assign it this way. So if we look at it, this one, which one works? Only one of them works. If we try to assign toy to robot, we can try and think of it in this way. Is toy a robot? A toy is not a robot, so this does not work. This is called, this is toy, this is robot, and we're trying to assign toy to robot. So this is called downcasting, and it does not work unless we have an explicit downcast that's occurring. This one will generally work because a robot is a toy. This is called upcasting, and this is usually safe to do. Okay, let's just end with a question about abstract and classes and virtual functions. A common mistake over here, that a common point of confusion is, what are abstract classes? So basically when we have pure virtual function is we have a virtual function and we have equals to 0 is not implemented at all. That is pure virtual. When it's virtual, it has a bit of implementation, but it has a virtual keyword in front of it. An abstract class happens when there's at least one pure virtual function, and this means that whatever was in the abstract class, let's just say if toy is an abstract class, we cannot instantiate a toy object because it's an abstract class. So this concludes it, and thank you for listening.